All right, guys, so we have one more part of 9.3, and it is finding the trig functions of angles that don't fall in a quadrant. They fall on what we call the quadrantals, or so on the x or y axis. So I'm going to skip right now, just right down here to our definition of a quadrantal angle, and it's just what I said there. It's an angle whose terminal side is on the x or y axis. And this means there's no reference angle. Since it's on an axis, we can't draw a triangle like back to the x-axis. So it's always going to be, sliding all over the place, always going to be a multiple of 90 degrees, right? Or that's the same as pi over 2 if we're talking about radians. So since we can't draw reference angles for these, we're going to use what we call the unit circle, which is just like it sounds. It's a circle with radius 1. And we're actually going to use those definitions of our sine, cosine, tangent that we did back when we started 9.3 a while ago. And that was if we draw a triangle in this circle, we could label the sides using x and y. So x would be the horizontal side, y would be the vertical side, and usually instead of calling this the hypotenuse, we call it r. So we defined all of our trig functions with that triangle. So sine, which is opposite, so opposite of theta, all the way across here would be y, and the hypotenuse is always the same, that's r. So sine, SOHCAHTOA, opposite hypotenuse is now, slide enough, y over r. Cosine, we're going to define as x over r. Tangent is y over x. So very important values to remember. The other guys are reciprocal, so sine and cosecant. So that's r over y. Cosine goes with secant, r over x, and tangent goes with cotangent. So if you're given a point in the coordinate plane, we can actually use that too to find all of our sine, cosine, tangent, any of those that we need. So when we get a quadrantal angle, what we're going to do is we're going to create a point that's on that angle. So these are all 270 degrees. So I'm going to put our angle at 270, right? This would be 90 here, 180 degrees, 270 would be right here. And you could draw this line to wherever you want, but to make our lives easy, we say that we'll always go 1 unit. And here we went 1 unit down, so I should really put -1 unit. So if we put our x, y coordinate in the coordinate plane, it would be 0, -1, and that's what we would use for all of these values. So anytime we have x or y, we have that. Now for r and all of these, the radius, that's what we use for the radius of our circle. So if I went down 1, the radius of that circle is +1. So for all of these, any quadrantal angle, r is always going to be +1. So I'm just going to go right down my list using these x and y. So for sine, y over r, y is -1, r is 1. So that's -1. Cosine is x over r. Well, x is 0, r is 1, so that's 0. Tangent is y, which is -1, again from over here, over x. Well, we've got a -1 over 0, can't have a 0 in the denominator, so no solution. Cosecant, r is 1 over y, -1. That simplifies to -1. And I'll continue going down the list, just not talking about everyone's. R, x, y. So these would be all of our answers for the trig functions of 270. All right, so I'm going to do just a couple more examples here. I'm going to keep erasing this triangle up top and using it. So again, to find the value, first thing you do is you graph this angle. So 90 degrees is straight up top. Put your point that would be there. So this would be 0 for my x, 1 for my y. We're always using 1 as the radius to make our lives easier. And then since it's cosine, I'm using x over r. So x up here is 0. R is always 1. So our answer is 0. All right, let's try maybe one more degree and then we'll do 2 radians. Sine of negative 180. Negative 180, remember that means we're going down. 180 is halfway across our circle. So that point over there would be to the left 1 and then 0. For sine, we need y over r. So my y value is 0. R is always 1. And we get 0 again. All right, let's try out one of these radians at least down here. So negative 3 pi over 2. A quick way to change the radians, if you don't like them, is to remember that pi is equal to 180 degrees. So we can just substitute 180 in and just simplify. So 180 divided by 2 is 90. So this guy would actually be cosecant of negative 270. So I'm going to graph that. Negative 270, we're going past negative 90, negative 180, negative 270. This is just like we had for 90 before. My point here is 0 for the x, 1 for the y. Oops, I just wrote x. For cosecant, we need r over y. R is always 1. Y here is also 1. All right, guys, so try out the pair deck and let us know if you have any questions.